quick video to reintroduce the idea of maps, plans and their real-world counterparts. What we have here is a couple of diagrams, and we'll just use them for examples about how to use tools to take an accurate plan. Notice we're talking about accurate. And the whole point is that the plan should be similar, and we're talking mathematically similar, to the real object. And that means that all lengths are in proportion. In proportion means multiplied by the same factor. Okay, so all our letters to be similar shapes, they must have corresponding lengths that are in proportion. So we've got a question here where we've got 1 centimetre. It's supposed to represent 1 metre. This is a reasonably straightforward change. I don't think anyone would struggle with it, but I just want you to see what I'm doing with the units and the tool. So the tool, this room, I'll measure its width. It is 8.2 centimetre, or length. This is 8.2 centimetres long. And I can do a number of different ways of finding the answer. I can look at what happens as I go from this side to that side. What happens is the number doesn't really change, so that's multiplied by 1, but the units change from centimetres to metres. I could look and say, well, in the same units, what's happening? Well, I'm multiplying by 8.2. My preferred way to calculate these, which was useful when we come on to the later questions, is I want to know this value x. So I say x, and I'm doing equal fractions again. You've seen me do equal fractions a lot. Well, x is the real distance in metres, so the real distance is there. And my plan measurements tie up. So my plan is 8.2 centimetres long, and the plan scaling is 1 centimetre. That means everything in this reasonably cancels out, and I don't think anyone would be surprised with x being 8.2 metres long. I could do the width if I turn it 90 degrees by holding the shift key down and drag the rule around. I can then drag it into place, and this one is 5.1 centimetres long, so 5.1 metres wide. I can even do angles which are not at right angles. I could actually do how long is the edge of this carpet. So I drag that into place. The carpet would be, keeps rotating about the middle, which means you have to relocate. That carpet diagonally is 2 metres long, diagonally. So the real one would be is 2 centimetres long on the map. It would be 2 metres in real world. And what about going the other way? So I'm going to say I want to know the width of the piano on my diagram. I know in the real world it's 1.6 metres long. How do I find out on the diagram its length? Well, I did the same thing as I did here. You could play about with the numbers and move them and say, well, going this way, it's still not changing the number. Or I've got to go from 1.6 to 1, so I could go down 1 metre to 1.6, 1 centimetre to 1.6. That would still work. Formally, I could do it as d divided by its scale factor, 1 centimetre, because now we're talking about the plan, and we're talking real. We know it is 1.6 metres, and my equivalent would be 1 metre. Do all my multiplication across, and it should give me a distance of 1.6 centimetres on the plan. So real, and this is the plan distance. So let's just set that back down. Go 0. 2, from 0 to 1.6 as measured. Okay, so let's go on down. A quick thing, because of what happens to the lengths, if lengths multiply in the same way along their length, the angle between them doesn't change. So there's an angle. Keep going that distance, keep going twice as long, and keep going along here twice as much. The triangle is similar, the angle doesn't change. So angles must stay the same for similarity. And that's quite important. If they don't stay the same, you get distortions and things don't work out properly. That's one of the problems we have with real-world maps, that there are distortions. And I'll talk about that with part of the mapping. There's a little bit further on. This one reasonably straightforward, apart from the measurement, but we'll come down to the one where it's 250. There we go. So say I wanted to work out how wide is this house. I'm doing the outside measure. I've measured it to be 7.6 centimetres. So the wall, I now know, is 7.6 centimetres in the plan. In reality, I want to know how long is it. So to get there, I need to know what the scale is. And the scale they gave me is 1 to 250. Well, there's no units there. If there's no units there, it means that the units must be the same. So this must be 1 centimetre and 1 centimetre. Now, centimetres to measuring the width of a house, that could be a little bit awkward. So let's see about changing this into metres. So I'm going to leave the 1 centimetre on this side and change 250 centimetres into metres. So 250 centimetres is how many metres? Same idea as I've done above. I know one conversion, 100 centimetres is 1 metre. Rearrange it and I've got 250 divided by 100 multiplied by 1 is 2.5 metres. That's a conversion. I can do that conversion at any time, but it's handy to know that I can do it. So for each centimetre on here, 2.5, 5, 7.5, 10, 12.5, 15, 17.5, and then a little bit more, and I've got 0.6. Now, quick thought means I can actually do this number quite nicely by using arithmetic. If I want two lots of 7.5. 7.6 is going to give me 15.2, and I want to add to that half, which is 3.8. To get those two to add up, we've got a common factor of the 7.6, so we add them together to give me 2.5 is the same as 19 metres. So I've calculated it directly. Or to use a calculator method, I wanted the x value. Yeah. So x divided by the wall length, 7.6 centimetre, and that is equal to the reality wall, and it's in reality the wall is opposite the 250, so this is the map, and that 250 is equivalent to 1 centimetre. So these are the map, and that's the line, sorry. Line, bottom one's a map, top lines is reality. Do the rearrangement. So 2.5 that should be. To do the rearrangement, you get x equals 2.5 divided by 1 multiplied by 7.6. And on a calculator it will give you 19 metres. Okay. You can do that calculation stuff in the II Maths homework. So it's going on the left hand side from 1 centimetre to 5 metres. So when I go from 11 centimetres, I want 11 lots of this, which is 55 metres. And coming back the other way, I need to do the opposite, divide by 5. I'll show you on the calculation. So we want the small scale. So if I'm going from something which is 11, and I want to know that length, I now know two sides which are the same. 55. So this is 1 centimetre, is 5 metres, and I can calculate x, which is the small version. So this is the model, is equal to the real thing on the same side as this 140, and its ratio was the 5 metres. So the model length for that is going to be x is 140 divided by 5, 28 times 1, so 28 centimetres. Okay. Yeah, both parts are correct.